an old song that's called Windy and Warm. Nice bluesy song. All right, so today what we're going to begin to look at is the definitions of the trig functions. So this is where trig begins. Everything we've done so far is a part of trig, but it's background information. Now the trig begins. Okay, so to begin with, in 1.4, we're going to look at the definitions of the 6 trigonometric functions. There's a reason why there are 6. I'll show you what that reason is. First thing you want to get comfortable with is the terminology, and we have the sine, cosine, tangent, cosecant, secant, and cotangent, and then the various abbreviations. Okay, we'll use the abbreviations most of the time. So in this diagram, I'm going to have you draw a few things and label a few things because it's important that you understand what the basic definitions are then. Okay, so to begin with, what we're going to do is let's just put a point out here and label that xy. So you're just plotting a point on an xy coordinate system. And then the next thing that I'd like you to do is just draw a radius. Okay, that radius should connect. What's going on with this thing? Trying to be all fancy here, and sometimes it doesn't work very good. Okay, forget that idea. Let's just go like this. Come on. Okay, sometimes that works great, sometimes it doesn't. Let's just draw a radius, okay, like that. So that's my radius, okay, like that. And then what you want to do is you want to draw a circle. Just kind of sketch a circle. Okay, so we got that. All right. And it turns out that the trig functions are basically ratios of x, y, and r. And it turns out if you were to put x, y, and r in a ratio, then there's 6 ways to do it, basically. And that's why we have 6 different trig functions. Okay. So what I'm going to do then is the definitions are all coming from x, y, r. So if you look down at the bottom of or below this on your handout, you'll have the sine of alpha. And we do need to put like an angle alpha in there. So the sine of alpha is y over r. The cosine's x over r. And then the tangent's y over x. And then we can do this way. Cosecant's r over y. Secant's r over x. And the cotangent of alpha is x over y. So you're always saying a trig function of an angle. So you're always looking at an angle. And x, y, and r depend on what the angle is on a circle. And that you're always going to be at the origin 0, 0, okay, because you're looking at an angle in standard position. Okay, a couple of observations that you want to make on here is, well, what are the reciprocals? Remember, reciprocals just means that you're turning a fraction upside down, the value's upside down. So notice the sine and the cosecant, those two things are reciprocals. So let's write that down, and it's important that you know that. And then also notice the cosine and the secant, x over r, r over x, those are reciprocals. And then notice that the tangent and cotangent, y over x, x over y, are also reciprocals. So one of the things you want to do is you want to memorize the definitions of your 6 trig functions, know where they come from, how they relate to x, y, and r, and it's nice to know what the reciprocals are. Okay. Now r, if you look at the diagram, r is a radius. So since r is a radius is a distance, so therefore it has to be a positive number. That's another important thing to know. And then the next thing is, what is r in terms of x and y? Well, let's go up to our diagram and let's take a look at that. Well, if you went through and took this point straight down to the x-axis, you would get a right triangle. And one thing that you want to know from, your background, hopefully, is anytime you have a right triangle, and see, that's going to be alpha, you're used to seeing right triangles labeled A, B, C, okay? And A and B are what you call the legs of the right triangle. That just means they are the 2 sides that make the right angle. And then C is what's called the hypotenuse. Okay, students usually remember this from their background. So the Pythagorean theorem is a theorem that has been around for a long time, 2,000 years or more. The Pythagorean theorem states that anytime you have a right triangle, then if you square the two legs and add them together, that's going to be the same as the square of the hypotenuse. Okay, so in my diagram here, I want you to notice that, well, x would really be this side of the triangle, and then y would really be that side of the triangle. So you have a triangle that goes like this. You have an angle alpha, you have r, you have y and x, you have a right triangle, so that means that x squared plus y squared is equal to r squared from the Pythagorean theorem. So that's an important thing to know, is x, y, and r are related by the Pythagorean theorem in our diagram. Okay, so let's write that down. So we have x squared plus y squared equals r squared. Okay, a lot of times you'll see me write that backwards. It's all the same anyway. And the relationship, again, comes from the Pythagorean theorem. Okay, so that's what the trig functions are. They are ratios of x, y, and r in a circle. That's one way to look at that. Okay, and they boil down to having something to do with a right triangle. Okay, so let's go to the next page. And what we're going to do on the next page, just in order to get us comfortable with these definitions, we're just going to do an exercise that establishes the definitions. So the first thing that you have in this problem is, well, you're given a point. So see, you're given x is 9 and you're given y is 12. Okay, so you're given an angle alpha is in standard position and you're given a point. That's all it takes to find the 6 trig functions. Okay, so the first thing I would like you to do on this is, as we're learning this, I want you to draw a diagram of each situation. I'm going to kind of do this to the side so I can have enough room here. Okay, so what we want to do is we want to go ahead and let's just draw a circle. Okay, we can draw a circle around kind of like that. And then what we're really looking at is we're looking at the point 9, 12. And let's just sort of estimate where that is. Okay, it's we have some sort of a circle on here. And let's say that this is 9, and let's say that that's 12. Okay, so we have the point 9, 12, which means we have a radius of r, and then we have x is 9 and y is 12. So what you're doing is, based on that point, you're going to find the values of the 6 trig functions. The first thing you really want to do is you want to, find r. So you're going to use the Pythagorean theorem. R squared equals x squared plus y squared. So we'll have r squared equals 9 squared plus 12 squared. Okay, I'll move this over here. We can work this out. 9 times 9 is 81. 12 times 12 is 144. Add those two numbers together and you get 225. Okay, now 225 is not r. That's the square of the radius. So think about your background. What do you do to turn the r squared into an r? Right, you take the square root. Okay, so what you're going to have is you'll have r equals square root of 225. Now that's 15. Some of these things you'll know. Sometimes you're going to need to get your calculator out. So I'm going to just show you on a TI, you would go second x squared to get that to come out, and then 225, you would have that. So you're going to work with square roots quite a bit. So you would have r is equal to 15. Okay, now what you're ready to do, since you have x, y, and r, is you're ready to put together your ratio. So let's do this like this. Let's start by doing the sine is y over r, the cosine is x over r, tangent's y over x. Okay, it's important that you get those memorized as fast as you can. Then the cosecant is r over y. It's just the reciprocal of the sine. The secant is r over x. And then the cotangent is x over y. Okay, so now we just form these ratios. So the sine would be y over r, so that's 12 over 15. Okay, you can reduce that fraction. What you're really doing is dividing by 3. Okay, so if you divide the top and the bottom by 3, you're going to get an answer of 4/5. Okay, so the sine is 4/5. Okay, the way I do this is once I have the sine, then all I got to do the cosecant is just do the reciprocal. That way you don't have to reduce it again. So we got the sine and cosine. And we leave those as a fraction. We don't want a decimal. We just want a reduced fraction. Okay, next one is the cosine. Cosine's x over r, so that's 9 over 15. Again, we can reduce this fraction by 3. You can more than welcome to do that in your head. So that would give a ratio of 3/5. Okay, so we have that. And then the secant is the reciprocal of the cosine. So it's going to be 5/3. Okay. And then we move on to the last two. The tangent's y over x. So y is 12, x is 9. Okay, again, we can reduce this by 3. Okay, so we would get 4 over 3 would be the value of the tangent. And then the cotangent is just the reciprocal of the tangent. So that's 3 over 4. Okay, so see, if I give you a point, you got to start by finding the radius, and then you can formulate your ratios by knowledge of the definitions. Okay, I'm going to do one more, and then I'll let you do one. One of the things you're going to get into a lot is the idea of rationalizing a denominator. Okay, so let's go ahead and let's draw a graph on this. Okay, and this time I've given you the point -9, 5. So I'm just estimating this. I'm just going to say that's -9, that's 5. So our point is here, and what you'll have in your diagram then is if you draw a radius, you just oops, I kind of messed up. I'm having trouble with that today. Okay, come on. Now it's not doing what it's supposed to do. I didn't mean it to do that. Okay, well anyway, let me go through and just erase this. I'm trying to be all fancy and everything, and I don't need to be doing that. Okay, so let me try one more time. The radius goes from here to there. So there's my radius. Okay, and then what's happening is you have a circle going around that. Just it's a good idea to visualize how that circle is going. So that's what you have. So in this diagram then you have x is -9, y is 5. So that leaves you with finding the radius r. Okay. So again, we're going to do Pythagorean theorem. R squared is equal to x squared plus y squared. And a lot of times your answer will turn out to be a radical. So if that's the case, you don't want decimals, you just want radicals. So let's see, we're going to have parentheses, -9 squared, y is 5. So we're going to have r squared is equal to 81 plus 25. And I'll move this over here. So if you add 81 and 25 together, you're going to get 106. Okay, now what do you do to get r? Right, you want to do square root of both sides. And what you'll have on this is you'll have r is equal to square root of 106. And then that does not simplify or anything. So you're going to end up, we'll kind of see from time to time that you have to go through and reduce radicals. So I want to show you why this doesn't reduce before I move on and finish the problem. If you were to go through and make a factor tree, this divides by 2, so you would have like, let's see, that'd be 2 times 53. Well, both of those are prime numbers. So if you have to have at least 2 of something before you can simplify the radical. Let me give you an example, like if you had, say you had 28. Okay, and let's say that you were working with the square root of 28. Okay, well, if you did a factor tree, you would have like one possibility to be 4 times 7, and then 4 is 2 times 2. So see, this will simplify because you have 2 to the second. So there's 2 ways you probably would have learned how to do this. One way is just to write this as the square root of 2 to the second times 7. And then you need to know the square root of anything squared is itself. So you would end up having that simplified form. Okay, or you may have just done it this way. Okay, you can see that in your head that 28 is 4 times 7, and then the square root of 4 is 2, so that comes out of the radical. So you're going to do that from time to time when you're doing these problems. Okay, so we're going to have r is square root of 106, and now we're ready to go through and finish that. So you do want to brush up on how to simplify radicals. You're going to do that quite a bit in this semester. Okay, so the sines y over r, cosines x over r, tangents y over x. I recommend that you get those 3 memorized, then memorize what the reciprocals are. So the cosecant is the reciprocal of the sine, the secant's reciprocal of cosine, and cotangent is reciprocal of tangent. Okay, so what we're going to do on this is when we put this together, the sine's going to be y over r, so that's going to be 5 times the square root of 106. Okay, Now, we need to rationalize denominator. One of the things I'm going to do right now is the cosecant is just going to be the reciprocal of this. So I can take this and turn this upside down, and then that would be the simplified answer you would want for the cosecant. Okay, like that. Okay, but we have to rationalize denominator. So this is another thing that you need to review. And let me show you an example of this. Like if you had 1 over the square root of 3, you don't want that radical to be in the denominator, so you multiply by square root of 3 over square root of 3. You have to do the same to the top and bottom. And the reason this works is because you would get square root of 3 in the numerator, but then you would have square root of 9 or square root of 3 squared. And the idea is anytime you take a square root of something squared, it's just itself, so you don't have a radical in the denominator. So typically you're going to multiply by whatever that radical is. Okay, so what I'm going to do on this one is multiply by root 106 over 106. Okay, then if you go straight across, see what you'll have is you'll have 5. I'm going to write the answer over here. So I'm going to have 5 root 106. And then if you do the square root of 106 squared, then you just get 106. So that would be the answer. That's rationalized. And notice the cosecant was already rationalized, so we don't have to worry about that. Okay. Okay, now we do the cosine. The cosine is x over r, so that's going to be negative 9 over root 106, and you're going to have to rationalize that. So what we want to do on this then is, see, I can go ahead and do the secant right now. So if I turn this upside down, I'd have a square root of 106 over negative 9. And typically you don't want a negative in a denominator. If you have a negative fraction, which you have a positive divided by a negative, you have a negative answer. So you could either write it as negative in front of the fraction bar over 9, that's acceptable, or I don't care if you write it as negative square root of 106 over 9. Okay, it's just preference. It's not wrong to write negative 9 in the denominator, it's just preferred that you don't. Okay, so that's the idea. Okay, now what we need to do is we need to go ahead and rationalize our denominator on the cosine. So we multiply by root 106 over root 106. Answer is pretty easy to get. You're going to get negative 9 times square root of 106 all over 106. Okay, so that's what you would get for your answer. Okay, so far we've got sine, we've got cosecant, we've got cosine, and then we've got secant. Okay, like that. So now that leaves us with the tangent. The tangent's y over x. Y is 5. X is negative 9. Okay, so the preferred way to write that is not having the negative in the bottom. Either write it as negative 5/9 like that, or negative 5/9 in the numerator. That's the way I do it most times, just write it like that. That's preferred. Okay, then the cosecant, or the cotangent's the reciprocal, so it's x over y, so that would be negative 9 over 5. So now we've got the answers to our 6 trig functions. So there's some background knowledge in there. You have to know how to simplify square roots when that shows up, but you also need to be solid with rationalizing denominators, because that's the general form that we want to write that in. Okay. All right, now I'm going to go to the next page, and I'm going to pause my video and give you guys a little time to do this one. What I'd like you to do is just identify x, y, and r, draw a picture. I'd like you to draw a picture, even though you don't have to do these problems. And when you're learning this, it's a good idea to remember what the picture is and how it relates to a circle. Okay, so let's go ahead and let's check now. And let's see if we're doing the right thing. So on your diagram, you just need to show that you plotted the point negative 5, 12. And again, you just estimate that's negative 5 and 12, and that's good enough. And this is your radius, okay? So in the problem, you have x is negative 5 and y is 12, so you have to do the Pythagorean theorem to find what r is. So we're going to do r squared equals x squared plus y squared. Okay, so we're going to do negative 5 squared, and then y is 12, so we'll have 12 squared. So that's r squared equals 25 plus 144. You can use your calculator if you need to, and the numbers get big. So 25 plus 144 is 169. Okay, then what do? Yeah, you take square root of both sides and simplify the radical. Now, this one turns out to be 13. So you could use your calculator if you needed to, so the radius is 13. So you don't have to worry about radicals on this problem. Okay, this problem's actually pretty simple because everything's going to already be reduced. So the sine, you should have got y over r, so you should have got 12 over 13. Okay, the cosecant is just the reciprocal of the sine, so you should have got 13 over 12. The cosine is x over r, so you should have got negative 5 over 13. Okay, and then the secant is the reciprocal, so that's negative 13 over 5. It's a good idea to put the negative in the numerator. The tangent is y over x, so that's 12 over negative 5. But my preference would be that you either write it as a negative right in front of the fraction bar or negative 12 over 5. That's the way I do it, like that mostly. Cotangent would be the reciprocal, so that's negative 5 over 12. Okay, so those should be your answers that you came up with. That's a pretty straightforward problem because you didn't have to worry about reducing fractions or rationalizing denominators. And you'll see a lot of that on your homework. Okay, all right, so let's move on to the next page. And now we're going to look at triangles. First thing I notice is I didn't spell triangles right. Okay, so that should be like this. Okay. So what we're going to do is begin to look at some special triangles for a few minutes here. And I'm going to show you two types of triangles. We're going to start with what we call a 30-60 right triangle. And one of the things you need to do is you need to memorize this triangle because it's real important. It shows up a lot. So you have a 30-60 right triangle. So it turns out that you can always reduce the sides to 1, square root of 3, and 2. So one of the things I want to show you on this is this idea. First of all, these sides are related by the Pythagorean theorem. So I want to show you how this would work. Okay, basically your hypotenuse is c. So if you did a squared plus b squared equals c squared, well, a and b are interchangeable. Let's just say that's a and let's say that's b. So we'd have 1 squared plus square root of 3 squared equals 2 squared. So let's just kind of prove that this works. 1 to the second's 1. If you square a radical, the radical comes off because what that is that's just square root of 3 squared, and the square root of anything squared is itself. So notice you would have 1 plus 3 is 4, so it works. Okay, that's the idea. Okay, well, there's a couple of things that you guys want to memorize. Okay, and this is real important too. This is the smallest angle. Out of the three, 30 is the smallest angle, so that is also the smallest side. Okay, that's a good way to remember that. And then this is the biggest angle. 90 degrees is the biggest angle, so it's got the biggest side. Okay, 2 is bigger than 1, and 2 is also bigger than square root of 3, because square root of 3 is about 1.7. Okay, so it would go like that. That's the angle in the middle. So the side in the middle goes like that. So one of the things that you want to learn how to do is, see, this triangle could be, rotated and everything. So if you have 30, 60, 90, you want to remember, a lot of times I tell students that it's as easy as 1, 2, not 3, but square root of 3. There's a statement that I've heard called, it's as easy as 1, 2, 3. Well, this is as easy as 1, 2, square root of 3. So it goes like this. The smallest angle matches the smallest side. Okay, the biggest angle matches the biggest side. And then the middle angle matches the middle side. So it goes like that. So you want to do that logically and be able to put that together like that. Remember, it's as easy as 1, 2, square root of 3. Okay, so the next thing I want to show you is, where does this come from? How did people figure this out? Well, the idea is it really comes from a equilateral triangle. So this is an equilateral triangle, and we're just going to say all the sides are 1 for simplicity. And it turns out if you have an equilateral triangle, see, all three angles always add up to 180 in a triangle. We've learned that. So that would be 60, that would be 60, and that would be 60. Okay, it turns out that if you have a right triangle, what you can do is you can go straight down and form what you call an altitude of a triangle. And you can make that a right angle like this. And without going through all the geometric details on this, what happens on this is if you look at this triangle, this angle gets cut in half. So that's now a 30-degree angle. And this side, which was 1, also gets cut in half, and it's equal to 1/2. Now, those are some basic ideas that you get into in basic geometry. So what I'd like you to do is draw this triangle kind of out at the side here. We're going to look at the triangle that we formed by making this altitude. So I want you to just sketch out a triangle, and then that's going to be 30, that's going to be 60, and that's going to be 90. So what we have is this side is 1, and this side's a half. Okay, so what I'm going to do is we're going to find this side here. Now this is a leg, so it's either A or B. I'm just going to call that A. And then if we do A squared plus B squared equals C squared, well, what we get is this. We're going to leave A alone. B is going to be the other leg, so that's going to be 1/2 squared. And C is going to be the hypotenuse, so that's going to be 1. Well, let's work it out and see what we get. So we would get A squared plus 1/4, because again, you're doing a half times a half is a fourth, equals 1. Then you could subtract 1/4 from both sides to get A squared is 1 minus 1/4. Then you can get a common denominator. So I'm going to multiply that by 4/4. So what I'm going to get is A squared equals 4/4 minus 1/4. Therefore, A squared is equal to 3/4. Okay, and I'm going to pause there for a second and let you look over that and get that written down. Because what I'm doing is I'm doing the Pythagorean theorem. So I've got A squared plus B squared equals C squared. And I'm working with fraction arithmetic. Okay, now what do you do to find A? Yeah, it's always the same. You do square root of both sides. So what you're going to have is you're going to have A is equal to, and see, you can do the square root of the top and bottom separately. So you get A is equal to square root of 3/2. Okay, and square root of 3 is irrational and it doesn't reduce. So you would have now, I'm going to fill in this side right now is square root of 3/2. Okay, so now what we can do is you can actually take all sides of a triangle, and you can always multiply all sides of a triangle by the same number. And if you do that, you're not changing the angles. So what I'm going to do is multiply everything by 2, and that guarantees that the angles are still 30, 60. So this is going to be 2 now. This is going to be square root of 3 now. And then this side, the 2's cross out, giving you 1. So you have that 1, 2 square root of 3. So notice the 1 is opposite 30. The 2 is opposite the 90, and then the square root of 3 is opposite 60. So that's where that comes from. It's nice to know derivations. The higher you get in math, and it's good to get appreciation for where this stuff comes from. So what you guys need to have down is, first thing you got to know is you got to memorize 30, 60 triangle. The sides go 1, 2, square root of 3, and put them in the right places. It's incredibly important that you get that down. Okay, so I'm going to pause here just for a minute and let you look over that, and let's see if we have questions. So let me pause this. Okay, so let's move on. We're going to learn one other special triangle. We call this the 45-45 right triangle. And this is another thing that you want to get memorized, okay, because you're going to use it a lot. Okay, so memorize the triangle. And it goes like this. You have two 45-degree angles and a 90. And again, all those add up to 180. And since that's 90, these have to be 45, because these two angles here always add up to 90 degrees in a right triangle. Okay, so it turns out that you can reduce the angles to 1, 1, square root of 2. Okay, a couple of things that hopefully are logical to you. We have a geometric theorem that says if the two angles in a triangle are equal, then the opposite sides also have to be equal. So that's a good way to remember that. And the other thing is, if you do a squared plus b squared equals c squared, well, it works out. The legs are 1 and 1. So you'd have 1 squared plus 1 squared is equal to c, which is the hypotenuse. So if you work out the details, that's 1 plus 1 equals 2. So that satisfies the Pythagorean theorem. So how did people figure this out? And this actually goes back, into, I think, Greek times, if I remember right. because Greek civilization, they knew the Pythagorean theorem, they knew the how right triangles work, knew lots of geometry from your days of Euclid. So how are these three sides related? Again, it's the Pythagorean theorem. Okay, but I want to show you a derivation of this. So what we're going to do with this one is we're just going to make a square, and we're going to label all four sides of the square as 1. And of course, you know that in a square, all of the angles are also 90 degrees. So what I'm going to do on this is we're going to make what we call a diagonal. So we're going to cut that like that. So you want to draw that out. And then this would be the hypotenuse. So that would be C. Well, it turns out, and this is a geometric theorem that's well known, is in a square, the diagonal just bisects these angles. So that's going to be 45 degrees there, and that's 45 degrees there. So you have that 1, 1, square root of 2 triangle. So all we got to do is just C squared equals 1 squared plus 1 squared. So we get C squared equals 1 plus 1. C squared equals 2. Then if you square root both sides, you get root 2. So it goes like that. So one of the things you want to be able to do when you memorize this triangle is remember the triangles can be rotated in all kinds of different ways. So if you know you have a 45-45 right triangle, you want to memorize that the sides go 1, 1, square root of 2. Well, logically, see, the square root of 2 is like 1.4, so it's the biggest side, so it goes there. And then the ones have to go opposite the equal angles. So that's how you do that. Okay, so what you want to have down on this page is memorize the triangles, understand how they work in the Pythagorean theorem. It's really nice to know where these things come from, too, as a derivation. That's a good exercise for students to do, is derive these things. Okay, now we go to the next page, and I'll begin to show you what we're going to do with this. So the goal is going to be, if we look at triangles that have a 30, a 60, or a 90 in them, or a 45, one of these triangles, then you want to be able to figure out the exact answer on this. Okay, so what we're going to start with on problem number 6 is we're going to find the cosecant of 30. So as you're learning this, the first thing is you want to know what the definition of the cosecant is. So that's going to be r over y. Okay, the next thing that you want to do is you want to draw a picture of this 30-degree angle. So if you're in standard position, you're always going to be starting with the x-axis. So I'm just going to draw like a ray like that, and then let's draw a 30-degree angle like that. Okay, now what we're going to get out of this is, see, we're going to get a triangle. So you can go straight down like this, and if you go through and label this, this side is going to be x, which we can figure out from our basic triangle. That side's y, and then that's the radius of the triangle like that. Okay, that's the hypotenuse. Okay, so all we got to do is we got to identify these things. So really what we do is you have to fill this in. You know that that would be a 30-60 right triangle. The sides go 1, 2, square root of 3, and then make it logical. Okay, that's the small. Okay, so the 1 goes there, so y is 1. 2 is the big side, the biggest side, so that's the radius, so that's 2. And then square root of 3 would be opposite 60, so you would have that. Okay, so what you get in this problem then is you get x is square root of 3, y is 1, r is 2. So when you get the answer to the problem now, you're just going to do r, which is 2, okay, over y, which is 1. So that answer is equal to 2. So we would conclude that the cosecant of 30 degrees is 2. Okay, anytime we do a trig function of an angle, we always get some numeric value. There are times when it's undefined, which we'll begin to look at as we continue to go through this. Okay, so notice what I did on that is if I wanted to find the cosecant of 30, I look at the definition, then I sketch it out, and look at the triangle that goes along with that. So that's the idea. Okay. All right, so the next one, we're going to look at sine. So I'm going to do one, and then I'm going to let you try a few of these and see if you can get these down. Okay, one thing that's probably a good idea on this problem, first of all, the definition of the sine is y over r, so it's a good idea to write that down. If you can figure out what y and r is, then you have the answer to the problem. A good way to do this one is to go ahead and convert this. That's a radian measure, and you want to go ahead and change that to degrees. So remember, pi radians is 180 degrees, so we're just going to do 11 times 180 over 3. Okay, you should be able to do this in your head. 18 divided by 3 is 6, so that's 60. Okay, and then if you do that, that's going to be 660 degrees. Okay, like that, if you go through and multiply that out. Now you can go through and do a calculator on that too if you want to. So that's, I think I've got that too big. 11 times 60 is 660. I did something wrong. That's 11 pi over 6. I knew I was doing something wrong here. Okay, so that's 6, so my apologies. Let's do that again. Okay, so this would be 11 pi over 6 is what the problem was given. So 180 over 6 is 30, and then 11 times 30 is 330 degrees. Okay, let me just double check that. So 11 times 30 should be 330 degrees. Okay, so we have that. Okay, so let's sketch out 330 degrees. So let's, again, when we do standard position, we start there and then just sketch it out. This is a clockwise angle, and it goes here, goes there, so it's way over in quadrant 4. Then we need to just figure out the triangle. Okay, well, if this is 330 degrees, and if that's 360, then it means that has to be a 30-degree angle. And that's what you're looking at, is that angle that's between the radius and the x-axis. So what we're going to do is we're going to draw a triangle out of this. So I'm just going to go straight up to the x-axis. Okay, like that. Let me zoom on that a little bit so I can draw this bigger. Okay, so what we're doing then is you need to figure out what triangle you have here. Okay, so what we have is, if this is 30 and that's 90, then that's 60. Okay, and then the sides go like this. Again, this is the one that we say is easy as 1 to root 3. 1 is the smallest, so that means the 1 goes opposite the smallest angle. Okay, and then the 2 is the biggest. Okay, so that's going to go there. That's the radius, and then that means the square root of 3 is going to go here. Now, you got to be really careful about this now. So that's your triangle. So what you get then is you get this. X is this. X is square root of 3. Now be careful with y. Y would be how far down you are. It's not 1, it's -1. So you got to be really, really careful about the signs when you're putting this together. Now r is 2, and r is always positive. X and y can be negative, but r is always positive. So then you're ready to get the answer. So we know that y is -1. We know that r is 2, so that means we would get an answer on this. The sine of 11 pi over 6 is -1 over 2. Okay, that's it. Okay, so be really, really careful about your signs. This one, y is negative. If you're down below the x-axis, y is negative. Okay, if you're above, y is positive. And think about x too. And if you need to do this, sometimes students need to review that in quadrant 1, both x and y are positive. If you're in quadrant 2, negative x, positive y. If you're quadrant 3, both x and y are negative. And quadrant 4, x is positive, y is negative. You need to know that and understand that. If you understand how points work, then you've already got that down. Okay, so next thing I'm going to do is I'm going to pause the video and let you work on number 8. And just one problem to kind of get your feet wet a little bit on that one. Let's go ahead and work with tangent then. Okay, so let's go ahead and go through this. Let's see if you're on the right track here. So if you draw a 60-degree angle, you're in quadrant 1, x-axis is the initial side, and then you have your radius. Okay, what you always do now, when you look at a triangle, you always go straight down to the x-axis. You don't go over this way. That's wrong to go over that way. You always want to go straight down there. And then you got to think about what your points are. See, this point has an x and y value. So that would be r. This part of the triangle would be x. And this part of the triangle would be y. So really, you have to figure out x, y, and r. Okay, the tangent's definition is y over x. So if you can figure y and x out, then you got the answer to the problem. Okay, well, it's all about the 30-60 triangle again. So if that angle's 60, then that's 30. Okay, and then the sides go 1, 2, square root of 3. So it's a matter of putting them in the right spot. Now 1 is small, so 1 goes there. So that means x in this problem is 1. Okay, 2 is the biggest, so that's the radius. So radius is 2. And then y would be opposite 60. That would be the one in the middle. So that's square root of 3. Okay, so once you figure out what x, y, and r is, then it's easy to figure out the answer to the problem. So y is square root of 3. X is 1. So you would get square root of 3. So we would conclude that the tangent of 60 degrees is equal to the square root of 3. Okay, that's how you get that out of the triangle, is from that. Okay, so again, all I did was examples with 30-60, but the 45-45 would work the same way then. Okay, and you'll see that as we proceed through some of these. Okay, so let's move to the next page, and that's what you need to know about special triangles, is you use those to find trig functions when you're dealing with 30, 60, 45, and 90 degrees, and angles that boil down. They might be in a different quadrant, but they still boil down to 30, 60, or 45. Okay, next thing we want to do is talk about what a quadrantal angle is. So a quadrantal angle is an angle whose terminal side is on either the x or y axis. So your quadrantal angles are going to be 0 degrees, 90 degrees, 180 degrees. Remember, you're on an axis. 270 degrees, and so forth. Now, those angles get bigger and bigger forever, so you could also have 360, you could have 450, and so forth. You can even have negative angles. So like this would be negative 90, negative 180, negative 270. All these angles are coterminal to each other. To focus on this, though, we're mainly going to focus on 0, 90, 180, and 270. So we're going to look at finding the values of the trig functions at a quadrantal angle. Okay, so I'm going to go down to number 10, and what we're interested in doing is working with 0 radians or 0 degrees, which are the same thing. So what I want you to do on these problems as you're learning this is we want to go through and draw a diagram on this one. So the first thing I'd like you to do is just draw an XY axis. I'll put this kind of at the side. And we're interested at 0. We're at 0 radians. So we need to know what this point is, and we need to know what r is. So it's really a matter of what is x, what's y, and what's r. Okay, well, what you do is you're going to let r be 1 just because it's simple. So that's what you're always going to do on quadrantal angles. Let's just let r equal 1. You could let it be anything you wanted to, except any positive number except 0, and it still works out. But for simplicity, we're going to use 1. Okay, so what I'm going to do is let's draw, again, a radius to that point, and that's r equals 1. So based on your knowledge of graphing, you should be able to figure out what x and y are. So x is how far over you are, y is how far up you are. So think about this. What would x be? Yeah, x would be 1, since you're over 1. What would y be? 0, because you're not up at all. So what we would have is x is 1, y is 0, r is 1. Okay, and that would be the idea. So now we just apply the definition. So let's go ahead and write down sine is y over r, cosine's x over r, tangent's y over x. And then the cosecant is the reciprocal of the sine, secant's reciprocal of cosine, and cotangent's reciprocal of tangent. So again, you got to get those memorized so that you can do this. Okay, now it's pretty easy. So the sine would be y over r, so it's 0 over 1. So that means the sine of 0 radians would be 0. Okay, the cosecant, you can go ahead and do the reciprocal. It's r over y, so that's 1 over 0. Now, what do you conclude about dividing by 0? Okay, you can't divide by 0, so we're going to say that the cosecant of 0 radians is undefined. Okay, it's not 0, it's undefined. Okay, now we move to the cosine. The cosine's x over r, so that would be 1 over 1. So the cosine of 0 radians would be 1. The secant is the reciprocal, so it's still the same number, so the secant of 0 radians is also 1. Okay, the tangent. Tangent's y over x, so you'd have 0 over 1. And 0 divided by any non-zero number is 0, so the tangent of 0 radians is 0. Okay, the cotangent is going to be the reciprocal, so it's undefined. So we've got all 6 answers to our problem. So you're going to notice as we do these problems, there's kind of a pattern on this. So we have 2 zeros, 2 ones, and 2 undefined. So you'll typically have that pattern when you're working with quadrantal angles, although the 1 could be -1. We'll see that. So you'll always have 2 zeros, 2 that are 1 or -1, and 2 that are undefined. Always works that way. Okay? Okay, so what we're going to do next is I'm going to do one more, then I'm going to let you try to do 2 of these. That way we kind of get all of these put together. So I'm going to go through one more example and let you try part C and D. Okay, so on this one again, let's start by just drawing a diagram. Okay, now we're at pi over 2. And remember, pi over 2, 180 over 2 is 90 degrees. So we're up here. In radians, that's pi over 2, and degrees, that's 90 degrees. Okay, so what you want to do on this is you want to draw a radius, and we're going to let that radius be 1. That's kind of a key, is you always let the radius be 1. And then your job is to figure out what that point is. Okay, and again, just think about how high. X is how far over you are, y is how high up you are. So how far over are you? Yeah, that's 0, so x is 0. Y is how high up you are, what is that? Yeah, that's 1. That's the whole key, is once you have x, y, and r and know the definitions, it's easy to put together. So the sine is y over r, cosine's x over r, tangent's y over x, and then the reciprocals go like this. Okay, so it's just a matter of plugging in these numbers. So if the sine's y over r, then it's 1 over 1. So the sine is 1. Sine of pi over 2 is 1. Cosecant's the reciprocal of the sine, so it would be the same. So there's your 2 ones. Sine and cosecant are both 1. Okay, move to the cosine. The cosine's x over r, so that would be 0 over 1. So that would be equal to 0. Okay, the secant's the reciprocal, so that's 1 over 0. So there is one of your undefineds, like that. Okay, tangent's y over x, so y would be 1, x would be 0, so what's that? Yeah, that's undefined. Okay, and then the cotangent is x over y, so that's 0 over 1. So that would be equal to 0. Okay, so notice you kind of have this structure. You have 2 ones, 2 undefineds, and 2 zeros. That's the way it works. Now, as we do the next 2 problems, you're going to find that the ones may be -1. Okay, so that's the idea. So you need to be solid with doing this, and getting to a point where you can do this in your head is real important. You're always going to let r be 1. Now, one other thing I want to just mention on this, sometimes students get this backwards. If you do 0 divided by a non-zero number, you get 0. If you do a non-zero number divided by 0, you get undefined. I see students mix this up all the time. One way to remember this is if you have a number divided by 0, well, what word does that spell? That spells the word no, which means you cannot divide. Okay, that's one way to remember this. This one says, you can say 0 over n. That spells the word on. So that means you can get on with the division and get 0. That's one thing that I've come up with that helps students at least to remember that, okay? All right, now I'm going to pause the video and let you do C, and then be sure that you do D on the next page. You're basically going on to 180 degrees and 270. Okay, so let's go ahead and begin to take a look at this now. So if we do this again, you're always going to let r be 1. Okay, and then just think about how this goes. So x is how far over you are, so you should have got -1. Y is how high up you are, so that's 0. So you got to be careful about that. X is -1, and y is 0. Okay, so that's the whole key to getting these problems worked out, is to know what x, y, and r are. Okay, so the sines y over r, let's go ahead and do the sine and cosecant. So the sine would be 0 over 1. So the sine of pi radians is 0. The cosecant is the reciprocal, so that would be undefined. So you cannot get an answer to the cosecant of pi radians. Okay, the cosine is x over r, so you would have negative 1 over 1. So now you get a negative 1. Okay, and then the secant would be the reciprocal, so that's going to be 1 over negative 1, so that's also negative 1. So that's what you should get. Okay, the tangent's y over x, so y is 0, x is negative 1, so you should have got 0 for your answer there. The cotangent is the reciprocal of the tangent, so negative 1 over 0 should have given you undefined. Okay, so again, notice you have 2 zeros, 2 undefineds. Now this time you have 2 negative 1s. So you always get that. That's a good thing to notice on this. Okay, moving to the next problem. Now we're at 270 degrees. And again, this is really 3 times 180 over 2. So 3 times 90 is 270 if you convert that to degrees. Okay, so in your diagram, you're down on the y-axis. So again, you're always going to let r be 1. Okay, so how far over are you? X is how far over you are. That's 0. Y is how far down you are. So what do you use? Yeah, negative 1. Okay, so we have that. So that's what you have to get. That's the key to the problem. The rest of it is doing the definitions. Okay, so let's do sine and cosecant. The sine would be y over r. That's negative 1 over 1, so that's negative 1. Cosecant would be the reciprocal, so that's also negative 1. Cosine is x over r, so that's 0 over 1, so that's 0. Secant is the reciprocal, so that's 1 over 0, so that's undefined. Okay, tangent is y over x, so that would be negative 1 over 0, so that's undefined. And then the cotangent is x over y, so that's 0 over negative 1, so that's equal to 0. Okay, so again, notice the structure, 2 negative 1s, 2 undefineds, 2 zeros. Okay, that's it. So one of your goals is to be able to figure this out. And with a little practice, you don't want to really even have to write anything on your paper. You want to just be able to imagine what that point is, and then be able to quickly figure out x, y, and r, and then figure out the ratio. Okay, so you want to get the ability to figure this out down real quickly. Okay, so let's see. We're going to move on. Now we're going to get into some calculator stuff. So I'm going to pause this just for a minute here and get my calculator going here. And then we'll begin to look at some calculator stuff. Okay, so I'm ready to begin just showing you how to use your calculator on certain things. And one of the things we're going to do is I'm going to remind you of how you do some conversions on this that are pretty important. So we're going to just kind of go through and do a quick little overview of how to do some of these things on your calculator. So first of all, you want to get comfortable with your mode button. Okay, your mode button is going to have the ability to change from radian to degree mode. Right now I'm in radian mode. If I wanted to change to degrees, I just go over with the cursor key, press enter. Now I'm in degree mode. So if you're doing the sine or one of the trig functions, you want to make sure that the angle that you're using is either in degrees or radians. So you want to be able to go back and forth between those two. Okay. If you're going to enter something in degrees, minutes, and seconds, now you can learn to do it this way if you want to. So if you were putting 45 degrees, 12 minutes, 15 seconds, it goes like this. You put the 45, okay, then you go to second math to get the test to come up. So it's just second apps. You get angle to come up. Option 1, you press enter, so there's 45 degrees. Then you enter the 12. And then same thing, you go second to get that angle thing to come up. Okay, then you go to option 2, which is the minutes. Okay, and then you put the 15 in. And then this one's a little different. The second hand is right here. It's above the addition, so you got to go alpha and then addition, and then that puts that in like that. Okay. Now, a lot of times what they'll do, if you just press enter, it's going to go ahead and convert that to a decimal. So we've already kind of looked at how you do that. So you want to know how to enter that. That's kind of nice. The other thing that you can do on this is you can change to degree back to minutes and seconds. So like if you take this example right here, if you do 56.25, then if you go second apps to get the angle to come up, DMS, what that's doing is that's changing that back to degrees, minutes, and seconds. So if you press enter, then that takes that to 56 degrees, 15 minutes, basically is what that is then, okay? And then the other thing you can do with radians, just kind of to remind you, if you're going to convert to radians, you multiply by pi over 180. Okay, so if you wanted to take this degrees to radians, well, then you could just do this. You could just go 56.87 times pi, so get your pi key to come out, and then divide by 180. And see, this will give you a decimal radian like that. Okay, so that's what you would get if you change that in. If you do this backwards, if you want to go like to convert this, if you want to convert radians to degrees, then you go like this. You go 0.975, that's in radians. Then you do the opposite thing. You multiply by 180 and then divide by pi. You'd want to use your pi key, press enter, and then that would give this. And then if you wanted to change that to degrees, minutes, and seconds, you can go second, get the angle to come up. Then you can go option 4. You can just type 4, press enter. Now that's been changed into degrees, minutes, and seconds. So those are some of the things we've talked about before. So one of the things that we're going to do now is, since we're dealing with trigonometry, is we want to know how to put things in our calculator. And what we're going to do on these is we're going to round these to 4 decimal places. So first thing is, on this example 11, is you need your calculator to be in degree mode. So before you put this in, you'd want to press your mode button, and you would want to make sure that you're in degree mode. And you just highlight it and press enter, so now we're good. Okay. Now what we're going to do is just go to the cosine button. So you just press cosine. That's a negative, so you got to use your negative key. And then you do 363. And you don't have to put the degree symbol there. You can, but you don't have to, because the calculator knows you're in degree mode anyway. So now you just press enter. Then we'll round that off to 4 decimals like that then, okay? So if we do that, you'd have 0.9986, okay? So we'll just record that as 0.9986 is what we should get for our answer. Okay, the next one, number 12, again, we're dealing with degrees, so you want to be in degree mode. So you're going to press in sine this time, and then you put in the 9 degrees. Okay, and you can do it like this if you want to. You can go second, get the angle to come up, get degrees to come up, and then put in 30 minutes. So you can get your angle command to go up, and then go to option 2. So you can put it in like that if you want to. Press enter, and then we'll round that to 4 decimals, so 1650. So I'll just record that as 0.1650. Now you could also do this problem this way. You could go sine 9, and then you can go ahead and just write that as 30 over 60. That way I'm converting that to a decimal like that. You can put it in that way. To me, it's less time consuming to do it that way. That's the way I always do it. So just do it like that if you like to. Okay, now the next problem is radians. Since you have a pi, and you have to have a degree. If you don't have a degree symbol, then you're assumed to be in radians. So the first thing you'd have to do on this is go to radian mode. Okay, like this. Get that to put in. Okay, then we just put this in our calculator. So we're going to have cosine 21 pi over 8. Like that. Since we're in radian mode, it's going to understand what we're doing. So we just put in negative 0.3. And let's see, if we're going to round that to 4, you have 3826. The 6 has to go up to 7 because the digit after it's 5 or bigger. So that one we're going to round as 3827 like that. Okay, and then that's how you do that. It's a good idea to kind of go back and forth between radians, degrees. Another approach would be to do this. Let me show this. If you were in degree mode, I prefer that you just kind of be in the right mode when you do that. But if you're in degree mode, you could also do this like this. You could go cosine 21 times 180 over 8. Now see what that's doing is it's going ahead and it's converting that to degrees, and since I'm in degree mode, it'll give the same answer. Okay, so there's several different ways that you can do this. Okay, so I'm going to clear that off. I'm going to pause and going to let you do a few of these yourself, 14, and then go on to the next page and do 15. So we're going to just take time to do a couple of these problems and kind of see where we're at with this then. Okay. All right, so let's go ahead and see if you did this. This is degree mode. Okay, so I'll just show you how I'm going to put this in my calculator and see if you round this. I wanted you to round to 4 decimals. This is in degree mode, so I am in degree mode currently. So I should just have to go sine and then 65. This is the way I'm going to do this. If you did it a slightly different way and got the same answer, it's okay. So I have 65 degrees. Then I'm going to put in the 40 minutes. So I'll, in the angle command, option 2. So this would be one way to do this. So if you do that, let's see, that'll round to 0.911. And see, now you got the 4th decimal has to go up to 2. So you should get that answer right there. Okay. You could also go sine 65 plus 45 out of 60. That way you're converting it to a decimal. And you're doing it all at the same time. See, that gives the same answer. Okay. Okay, next page. Okay, this one needs to be in radian mode. So the way I'm going to do this is just take my calculator, change it to radian mode, and put that in like that. So I'm going to put in cosine, the cosine button. I'm going to put negative. Be sure you use the negative button instead of the subtraction. Use the pi key, and then divide by 8. And then we'll round that off. So if I'm in radian mode, you should get 0.38, and let's see, 26. The 6 has to go up to 7, like that. So that's 0.3827 is what you should have there. All right, so you want to be sure that you know how to enter trig functions of this type into the calculator. I'm kind of focusing right now on sine, cosine, and tangent. I didn't do a tangent, but you have the tangent button. So we'll get to a point where you do the secant, cosecant, and cotangent in a little bit here. So let's focus on this. Okay, next thing we want to go ahead and look at is a little bit more with the calculator still. So let's kind of review our definitions. So let's write these down. You want to get these as fast as possible. The sine's y over r. Cosecant's the reciprocal. Cosine is x over r. Secant's r over x, tangent's y over x, cotangent's x over y. Okay, now what did I say about r? What kind of number is it? Yes, it's a positive. Now, why is it positive? What does r represent? That represents a radius, so therefore it's representing a distance, and distance is always positive. Okay, so what we're going to do is kind of look at the signs, and we're going to kind of go through a process on this. So let's think about where x is positive. So let's kind of go through and look at the different quadrants, and we're going to reason out something about the trig functions, which is real important. Okay, so if you're in quadrant 1, x is positive and y is positive. Okay, so the value of x is positive in 2 different places. Okay, let's go over and let's quadrant 2. Quadrant 2, you're going to the left, so x is negative, y is positive. If you're in quadrant 3, you're going left and down, so x is negative, y is also negative. And then if you're in quadrant 4, you're going over and down, so x is positive and y is negative. So let's look at x. X is positive. Where are the 2 quadrants where x is positive? Okay, there and there. So we're going to get that in quadrant 1 and quadrant 4, x is positive. You don't want to memorize that. You want to figure it out as you need to. Where is x negative? Well, x is negative in quadrants 2 and 3. Okay, so that's kind of an important thing to quickly know. The way I think of it is x is positive to the right and x is negative to the left. Okay, Now let's look at y. So where is y positive? I think this was supposed to be y is positive, so I'm going to change that. So where is y positive? Y is positive in 1 and 2. In other words, it's positive when you're going up. Where is y negative? Okay, it's when you're going down, so that's quadrant 3 and quadrant 4. So you don't want to memorize that. It's easy to remember that x is positive to the right, x is negative to the left, y is positive up, and y is negative down. So that's important. Okay, now what we're leading up with this now is we're going to do a few problems, and then we're going to start getting into quadrants where you have to pay really close attention to whether the trig function is negative or positive. So to start with, let's look at this example. This is just some exercises to review the triangles. So we're going to plug in 45, and we're going to work out 11 times the cosine of 45 degrees. Okay? So the first thing is we are in quadrant 1, and let's draw a 45-degree angle. You're in quadrant 1. So if you draw this angle in standard position, you're like that. And we're going to make a triangle. So we're going to go straight down to the x-axis. And then you want to think about how the sides go. Remember, on the 45-45 right triangle, the sides go 1, 1, square root of 2. So if you fill this in, this would be x, that would be y, that would be r. Okay? Now, these are the two equal sides, so it should make sense that they go there. They're opposite 45, and r is square root of 2. So what you do in this problem is you do this. You have 11. Now the cosine's definition is x over r. So x is going to be 1. R is going to be square root of 2. So you're going to end up with 11 times 1 over the square root of 2. So you end up with 11 over square root of 2. Okay, you got to get that information from the 45-45 right triangle. So again, we just have cosine is x over r. So it's 1 over square root of 2. Okay, now we're going to rationalize. So how do you rationalize this denominator? Yeah, you want to multiply by square root of 2. And when you do that, the numerator is 11 times square root of 2. The denominator is really square root of 4, or square root of 2 squared, so that's 2. So that would be the solution to that problem. That's just a review of right triangles and the definitions of trig functions now that we know them. Okay, next problem, we're going to do this. So we're going to again look at a 45-degree angle. So we're looking at the sine of 45 degrees all over 6. Okay, well, what is the sine? The sine is y over r. So I'm going to do that, and I still got the 6. Now you're going to have a complex fraction. So look at the diagram. In this diagram, y is 1, r is square root of 2. So if we do the sine of 45, we're going to have 1 over the square root of 2, and then all over 6. Okay, now this is a complex fraction. Don't let this bother you. This is a division problem. What's really going on is you have the numerator divided by the denominator. So we're going to put the 6 over 1, and how do you divide fractions? Okay, you multiply by the reciprocal, so you'll have 1 over square root of 2 times 1/6. So the answer to this problem is 1 over 6 times square root of 2. Okay, and again, the purpose of the problem is to get you comfortable with triangles, arithmetic, and your definitions of your trig functions. Okay, that's why the exercise is important. Okay, now we're going to transition into something different. This is another exercise on number 18 intended to get students comfortable with the trig definitions. Okay, so the first thing that we have on here is we're going to ultimately find the tangent of alpha. Okay, that's what we're ultimately going to find in this problem is we need to figure out what the tangent of alpha is. So the first thing you got to know is what is a tangent. If you're going to find a tangent, you got to know y and x. So ultimately in this problem, you got to figure out x and y. If you do that correctly, you should have a correct answer. Okay. Well, you're given a clue on this problem. You're not given x, y, and r, but you're given enough information to figure it out. So let's write down that we have cosine alpha is 1 over 4. Okay. So look at the cosine's definition. The cosine's definition is x over r. Okay, so that means we have r is 4 and x may be 1. It could also be -1. So we're not really sure right now if x is plus or minus. And that's where this clue comes in. And you got to put these two things together to figure out what quadrant you're in. So here's the way I show students how to figure this out. Okay, so first of all, what we need to look at is we need to look at where the sign is positive and where the cosine's positive. Okay, well, okay, the sign is y over r. So we need to figure out where the sign's positive. Okay, the sign is going to be positive wherever y is positive. Where is y positive? There and there. So you're either going to be in quadrant 1 or quadrant 2. Okay, that's because I'm giving you the sign is greater than 0, so I'm saying where's the sign positive? Okay, the sign turns out to be positive where y is positive. Okay, now I've also given you that the cosine's positive. See, I gave you a 1/4. So what we need to do is look at the cosine's definition, which is x over r, and let's figure out where is x over r positive. Okay, well, that's going to be where x is positive, because r is always positive. So x is positive that way, so that means that you're going to be, the cosine's positive there and there. So where do these two check marks overlap? They overlap in quadrant 1. So that means that you are in quadrant 1. So you have to figure out what quadrant you're in order to figure out what x and y and r are. Okay, so here's what we have now. We have x is 1, and it's positive because we're in quadrant 1. R is 4, and it's positive because r is always positive. Okay, so what we have to do next is we got to figure out y, and we do that by the Pythagorean theorem. Okay, so I'm going to just erase part of this diagram so I'll have a little bit of room to do this then. Okay, so let's see. We have x squared plus y squared is equal to r squared. So we should now be able to easily figure out what y is. So x is 1, so that's 1 to the second, plus y squared is equal to 4 squared. So that's 1 plus y squared equals 16. You can subtract 1 from both sides. So you're going to get y squared is equal to 15. And then square root both sides. You really get y is plus or minus root 15. So you have to figure out, is it positive or negative? Well, the thing is, we know we're in quadrant 1. Okay, and if you're in quadrant 1, well, x is positive and y is positive. See, once you determine we're in quadrant 1, you know both x and y are positive. So that's going to be positive square root of 15. Okay, the trickiest part of the problem for students usually is figuring out what quadrant you're in. So I've given you two clues. I've given you cosine's positive, and cosine is positive where x and r are both positive. And then I gave you y is positive. That's where y is positive, so that puts you in quadrant 1. So now we're ready to get the answer. The tangent's y over x, so y is square root of 15. X is 1. So we get for our answer square root of 15. So that is the final answer of the problem. Okay? All right. Now I'm going to continue to kind of go through the quadrants, and then I'm going to show you a way to kind of reason this out when we finish up the section. So the next thing I'm going to do is I'm going to go ahead and go through number 19. Before I do that, though, I think it would be wise for me to go to the last page of your handout and go ahead and show you a little bit more in detail how you can figure out where the trig functions are positive and negative. Okay, so okay, so let's actually do that, because I think you're going to need to look at this. Let's go all the way to the last page, and I've given you a couple of things to help you remember where things are positive. But I want to show you where it comes from, first of all, before I go through these ways to remember this. So here's what I would like you to do. Just kind of at the bottom of the page, I would like you to draw out a kind of a big XY coordinate system here. Okay, and in each quadrant, let's write down what x and y are. Okay, let's start with quadrant 1. Okay, in quadrant 1, both x and y are positive. It's important that you understand that. Okay, in quadrant 2, it's important that you understand that X is negative and y is positive because you're going left and up. That means negative x, positive y. If you're in quadrant 3, x is negative, y is negative because you're going left and down. It's incredibly important you know that. If you're in quadrant 4, x is positive, y is negative. Okay, so that's real crucial on this. So here's basically what you can do. So what I'm going to have you do is write down sine of alpha, cosine alpha, tangent of alpha in each quadrant. So I'm going to let you go ahead and take a minute to get this written down in every quadrant. And our goal is to figure out if we get a positive or negative answer for the trig functions in the various quadrants. Okay, so I'm going to show you a couple of ways to figure this out. And your goal is to be able to figure this out very quickly without having to write all this stuff down all the time. Okay, so what's real important when you figure this out is you have to know the definitions. Okay, so I'm going to write these down as we go. The sine is y over r, the cosine is x over r, and the tangent is y over x. Okay, so if you went through and did this, see, everything's positive, and r is always positive. It doesn't matter what quadrant you're in. So if you're dealing with x, y, and r in quadrant 1, you're always going to get a positive result. So the sine would be positive over positive, so you would get a positive answer. Okay, if you do a sine of a quadrant 1 angle, you will always get a positive answer. Okay, let's go to cosine. Cosine is x over r, so x is positive, r is always positive, so that's positive. Okay, tangent's y over x. Y is positive, so is x, so you get a positive over a positive, so you get a positive. So what I just showed you is this. I'm going to show you something with the calculator real quick, and I'm going to get in degree mode just because I think it's easier for students to interpret. So here's what happens. If I did a sine of a quadrant 1 angle, notice I get a, whoa, hold on, I must be in the wrong mode. I must have never changed. Yeah, that's what I did do. Okay, I need to get in degree mode. I think I forgot to press enter. Okay, so now I'm in degree mode. Okay, so if I clear everything off, here's what I just showed you. Pick a quadrant 1 angle. 20 degrees is quadrant 1. Notice I get a positive answer. If I do cosine of 89, 89 is a quadrant 1 angle. I get a positive. If I do a tangent of a 23 degree angle, I get positive. So everything is positive in quadrant 1. If you do a trig function of a positive angle, quadrant 1 angle, you're going to get a positive. Let's go to quadrant 2. Okay, so it works like this. Okay, the sine's y over r. So you'd have positive over positive, so you would get a positive. Okay, the cosine is x over r. So x is negative. R is always positive, so you get a negative answer. The tangent is y over x. Okay, y over x, so y is positive. X is negative, so you get a negative answer. So here's what I just showed you, and we have a way to figure it out. You don't want your calculator to just answer everything for you because you're not learning this as deeply as I want you to. So let's pick a quadrant 2 angle, okay? Like if I did the sine of 91 degrees. 91 degrees is in quadrant 2. Notice I get a positive answer. If I do a cosine of 91 also, I'm going to get a negative answer because that's a quadrant 2 angle. If I do the tangent of 91 or any quadrant 2 angle, I'm going to get a negative. Okay, so that's what I'm showing you is how to figure that out, see. Okay, so it's going to be a little bit different in every quadrant. Okay, let's go to the next one. Sine is y over r. Y is negative. R is always positive. Okay, remember we have x and y are both negative in quadrant 3. So that means we get a negative answer for the sine of a quadrant 3 angle. Cosine is x over r. X is negative. Y is positive. So the cosine of a quadrant 3 angle is also negative. Okay, tangent's y over x. So we'd have negative over negative. So what do you have? You have a positive. Okay, so again, what I've shown you on that is this. Let's just keep it simple and work with a quadrant 3 angle. Quadrant 3 angles are always between 180 and 270. So let's pick something like 185. If I do the sine of 185 degrees, notice I get a negative answer on the calculator. If I do cosine, let's say 192, that's also a quadrant 3 angle. Notice I get a negative answer. Okay, if I do tangent, I'll just pick any quadrant 3 angle. 200 is quadrant 3. Notice I get a positive answer. So that's what I just showed you, is negative, negative, positive is how it works in quadrant 3. Okay, and finally, let's go to quadrant 4. So quadrant 4, sine is y over r. Y is negative. R is always positive, so that's negative. Cosine is x over r. So you'd have positive over positive, so you'd have a positive. And then the tangent is y over x, so you'd have negative over positive, you get a negative. So again, what would happen is if you did on your calculator, if you did something like sine of 300, you would get a negative answer. If you did cosine of, say, 359, you would get a positive answer. If you did tangent of, say, 271, you would get a negative answer. Okay? So what your job is this is such an important thing in trig, is you want to be able to figure this out quickly and efficiently. So what I'm going to show you how to do is a couple of ways to figure this out quickly and efficiently. Okay, here's how I do this. If I'm doing the sine is y over r. So the sine is positive wherever y is positive. Where is y positive? Up there. Okay, so notice the sine turned out to be positive up above, 1 and 2. Okay, where is the sine negative? The sine is negative where y is negative, so that's just going to be down below. Okay, so you're positive above, you're negative below on a sine. So notice that the sine turned out to be positive upstairs, negative downstairs. And it's easy to figure out because the sine's y over r, and r is always positive. Okay, if you move to the cosine's x over r, so it becomes a matter of where is x positive. Okay, so x is positive to the right. So notice how the cosine turned out. The cosine turned out to be positive when you're to the right, and it turned out to be negative when you're to the left. And that's just the way x works. X and y work. Okay, so that's how I remember that. And then the tangent is y over x. So what it turns out to be is where the signs are the same. Okay, so if you're in quadrant 1, you have both x and y are positive, and if you're in quadrant 3, x and y are negative. So the tangent turns out to be positive here and there, okay, in opposite quadrants, and it turns out to be negative in opposite quadrants. So it's where x and y have the same sign. So that's one way you can figure that out. Now, the other thing I want to mention on this, too, is I only did 3 trig functions because, see, it's all the same. If you went to quadrant 1, the cosecant, the secant, and the cotangent are going to, since all they are is reciprocals, is they're just going to be the same anyway. Okay? So what you would end up having there is, well, everything would be positive there. Okay? And then if you're in quadrant 2, both the cosecant and the sine are positive. Both the secant and cosine are negative. Cotangent and tangent are negative. Okay, so once you figure out 3 of those, then the reciprocal functions work the same way. Okay, now these diagrams here are a couple of quick ways to remember this. There's 2 ways that I see used a lot. One way is all students take calculus. And what this just means is all of the trig functions are positive. And that would include all 6 of them. So in quadrant 1, if you do a trig function of a quadrant 1 angle, you get a positive answer. The students means sine is positive. Okay, that's what that's standing for. Then the cosine and tangent are negative. Okay, and then technically this would work out this way. Sine and cosecant are positive in quadrant 2. Everything else is negative. If you go to quadrant 3, it says take calculus. That stands for tangent. So what you get is the tangent's positive, the other 2 are negative. So if you're in quadrant 3, it's going to be the tangent and cotangent are positive, and then the other 4 are negative. And then finally you get the C for calculus. C stands for cosine. The cosine is positive. So if you're in quadrant 4, it's the cosine and secant that are positive, and then the other 4 are negative. So you can learn these jingles. There's all students take calculus. There's also all science teachers crazy. If you learn it that way, just don't tell your science teacher, okay? But either of those two ways are efficient ways to learn this. Okay, now what I'm going to do now is I'm going to go back to, let's see, where we left off. So let's see, we need to go to problem number 19. I'm going to do problem number 19, then I'm going to let you do a couple of problems, and then we have a few things to wrap us up with the section. Okay, so one of the things we want to do on this one is I'm going to change this problem. I don't really like this problem, so we're going to find the secant, and I'm going to give you two things. I'm going to give you that the sine of alpha is -1/2, and then I'm going to give you that, I'll also give you that the cosine of alpha is less than 0. I want to change the problem because it's I don't need to give you a cosine. It's a little better this way. Okay, so here's what you do. One of the first things you want to do is just figure out what quadrant you're in. So what we're going to do is we're going to draw a diagram, and we're going to do that. So notice that I'm giving you a negative sign. Okay, the sign is negative down below because the sign's y over r, and y is negative down below. So that means in this problem, you're either going to be in 3 or 4. Okay, I've also given you the cosine is negative. Well, the cosine's x over r, so it's negative to the left. So the cosine's negative here and there. Okay, so that means that the two conditions overlap in quadrant 3. So that means that you are in quadrant 3. Okay, you always got to figure out what quadrant you're in. So if you're in quadrant 3, x is negative, y is positive, and then r is always positive. Okay, so that's what you got to do in the problem. And ultimately in this problem, we're going to figure out what the secant of alpha is equal to. That's our goal. Okay, so the next thing we do is I gave you the sine of alpha is -1/2. The sine is y over r. So that's going to tell you immediately in this problem that y is, oh, hold on, negative. I did a real stupid thing here. Of course, I caught that, so that's negative, so actually the sign's going to be negative. Sorry about that. Okay, so we got that. So that means y is -1 and r is 2. Okay, since we're in quadrant 3, both x and y are negative. Okay, now the next thing we got to do is we got to do the Pythagorean theorem. So we're going to have x squared plus y squared, y is -1, is equal to r squared. So we do that. So that would be x squared plus 1 is equal to 4. Subtract 1 from both sides. You're going to get x squared is equal to 3. Then you square root both sides, you would have x is plus or minus √3. But x is negative because we're in quadrant 3, so you'd have that. So the whole key to this problem is figuring out x, y, and r. It's an exercise in correctly figuring out the 3 variables x, y, and r. So now the secant's definition is r over x. So all we should have to do is take r, which is 2, x is -√3, and then we can rationalize the denominator. So you can multiply by √3 over √3, and we have a negative answer, so we would have -2√3 over 3 would be the final answer to that problem. Okay, now the problem, there's a lot of thinking in it. There's not any real complicated arithmetic or mathematics, but there sure is a lot of thinking in it. So you have to basically figure out x, y, and r, and I always give you enough information to figure that out. I generally give you one trig function and a clue that'll help you figure out what quadrant you're in. Okay? All right, so we're going to try a few of these and just kind of put you to work and see what you can do on these then on the next page. Okay, so let's do 21. I'm going to let you guys do 20 and 21 on the next page. I'll pause the video and give you a little time to work that out. Okay, so let's go ahead and do this one, see how you did on this one. So first of all, you would be working out 12 sine of 45 degrees. Okay, and your goal on this one is know the definition of the sine and know how the right triangle works. So the sine's y over r, so ultimately you're doing 12 times y over r. And you got to think about your triangle. So one thing that you probably would want to do is draw a picture of the 45 right triangle. So you're in quadrant 1. That's 45. You have a right triangle. Okay, and remember it goes, that would be x, that side would be y, that side would be r. So this is a 45 right triangle. And it's going to go 1, 1, square root of 2, with both x and y being positive. So you'll have 12 times 1 over square root of 2. Okay, so again, you got y over r. So you're going to have 12 over square root of 2. And then what you need to do is rationalize the denominator. Okay, so if I do that, you're going to have 12 times the square root of 2 over 2. Now, you can reduce the 12 and 2 on that because you got multiplication going on. Okay, and it's only because of that multiplication. If that was addition, you couldn't do that. So 12 over 2 is 6. So the answer I would like you to have gotten was 6 times the square root of 2. Okay, so that's the idea. Okay, now the next problem, okay, what we're doing on this one is, I think a good starting point on these problems is always trying to figure out the quadrant you're in. Okay, and see, you were given two conditions. You were given the sine of alpha is negative 3/5. Okay, and see what the deal is the sine is y over r. Okay, what's going on with my thing here? Something's screwing up here. Let me write that again. So we have the sine of alpha is negative 3/5. Okay, the sine's y over r. Okay, so what that means is if y is negative, remember y is negative downward. So that means you either have to be in quadrant 3 or 4. Okay, I also gave you the cosine of alpha is negative, and the cosine's x over r. So if the cosine's negative, that means that you have to be this way. So you're either there or there. So the two check marks overlap there, so that means you're in quadrant 3. Okay, what that would tell you is x is negative and y is negative. Anytime you're in quadrant 3, both x and y are negative, and then r is always positive. So that's real critical in these problems. Is the first thing you ought to do is figure out what quadrant you're in. That'll tell you if x, y, and r are negative or not. Okay, all right, now what we have is if you look at this right here, y is negative 3 and r is 5. Okay, and see the negative has to go with y because r is always positive. So that's positive. Y is going to be negative 3. Okay, now what you got to do is you got to figure out x. So we're going to do x squared plus y squared equals r squared. So we have x squared plus negative 3 squared equals 5 squared. So that's going to be x squared plus 9 is equal to 25. You can subtract 9 from both sides. And if you do that, you're going to get x squared equals 16. Square root both sides, you end up getting x is plus or minus 4. But since we're in quadrant 3, x is going to be negative 4. Okay, so now what are we doing? We're finding the secant. So to get the final answer, the secant of alpha is r over x. R is 5. X is negative 4. So the best way to write the answer would be negative 5 over 4. Okay, so there's a lot of thought going into that. You got to know these things. You got to figure out the quadrant you're in. Then you got to figure out, what two variables you're given. In this case, you're given y and r. Okay, and then you got to use the Pythagorean theorem to find the next one. Okay, like that, and then pull out the definition. Okay, those problems are excellent exercises to get students comfortable with lots of details in trigonometry. Okay, so the next thing we're going to do is just kind of finish up by focusing on a little exercise in what quadrant you're in. Okay, so here's the idea. You're given two clues. You're given the cosecant and you're given something about the cotangent. Okay, first thing I'm going to do is I'm going to write down cosecant of alpha is greater than 0, meaning that's positive. Well, the cosecant is r over y. Remember, r is always positive, so you got to figure out where y is positive. Okay, y is positive upstairs, so that means I'm going to put a check mark there. So that means that we are either in quadrant 1 or 2. Okay, so we got that. That's where the cosecant's positive is there. Okay, next thing I'm going to do is I'm going to write down the second condition, which is the cotangent of alpha is positive also. Well, the cotangent's x over y. Okay, so what you're going to have, there's two possibilities. You could either have positive over positive, or you could have negative over negative. Okay, positive over positive, x and y are both positive in quadrant 1. X and y are both negative in quadrant 3. Okay, so what you get then is the answer to this problem is where the two overlap, so that means you're in quadrant 1. You're trying to find the quadrant where you have a cosecant being positive and a cotangent being positive. There's only one possibility, and that's quadrant 1. Okay, again, definitions are kind of key. Okay, let's do the next one. Is that the same problem? Yeah, I think it is. So I'm going to change this problem also. Okay, let's just totally change this, and let's do this. Let's say we have cosine of alpha is negative, and let's say that we have the tangent of alpha is also negative. Okay, let's see if we can figure that one out. Okay, so let's see. Let's do this. Let's go ahead and draw an xy axis. So let's start with the cosine of alpha is less than 0. Okay, well, the cosine's x over r. So remember, what you're going to end up with, r is always positive, so the question is, where is x negative? X is negative that way. So the cosine is negative either in quadrant 2 or quadrant 3. So that takes care of that condition. We now know that we can't be in either of those two quadrants. Okay, now the next thing we're going to look at is the tangent. Okay, so let's write that down. We have tangent of alpha is less than 0. The tangent's y over x. So there's two places where this happens. You could either have negative over positive, or you could have positive over negative. Okay, well, y is negative and x is positive here. That's where that happens. You have a negative y and a positive x, and then this happens. You have a positive y and a negative x. That happens here. Okay, in this quadrant. Okay, so that means the tangent is going to end up being negative here or there. So that means the answer to the problem is here, so you're in quadrant 2. Okay, so again, what we established is the cosine's negative here, tangent's negative here, so they overlap there. Okay, so we got one last thing to do to kind of finish up. I'm going to have you guys do the next two problems. This one's okay, but I'm going to change 24 because I think it's the same problem. I'm kind of sloppy about doing that. So on 25, let me change this to sine alpha is positive and cosine alpha is negative. So I'll let you do those, and then that'll wrap up the section. Okay, so I'm going to go ahead and just kind of see what you came up with. Okay, so this one we have secant alpha less than 0. Secant's r over x. So the question is, where is x negative? X is negative down there. Okay, so that's where the secant would be negative, would be in those two places right there. Then we have the cotangent of alpha is also negative. Well, the cotangent's x over y. So that means you could either have a negative over positive, and in that case, x is negative and y is positive here, and then you could have a positive over a negative, okay, and that would be over and down, so that would be there, okay. So what you'd find on this is the cotangent's negative here and there. So what did you come up with? Yeah, quadrant 4 is the right answer on that. Okay, next thing we want to look at on the next page, let's see if we did this one okay to kind of finish this up here. And what we would have is this. Okay, so the sine, think about where the sine's positive. Okay, the sine's y over r. R is always positive, so the question is, where is y positive? Y is positive up. So you would be there or you would be there. Okay, so right now your answer is, you've narrowed it down to either 1 or 2. Okay, next condition is I gave you the cosine's negative. So if the cosine is negative, remember the cosine is x over r. R is always positive. Where is x negative? So x is negative to the left. So that means you would be there or there. So the conditions overlap there. So what quadrant are you in? It's quadrant 2. That's a very important activity to be able to do. Okay. So this section, that'll wrap us up with this section. There's a lot of really, really important things in this section. And it's a lot of picky details. There's a lot of things you need to be solid with. Is you want to make sure you know the definitions of the trig functions. You want to have memorized the special triangles. You want to be able to figure out where things are positive and negative, and so forth. That's a real big, important section. So your ability to have all this information down quickly and memorized is going to be very, very important in this section. Okay, so that will wrap us up, and hopefully this will help you to learn the material in this section. Hope the homework goes good.